Okay, let's take a look at explore number 2, types of energy. And our essential question: how does the kinetic energy of an object relate to its mass and velocity? How does the kinetic energy of an object, right? Every object that is in motion has kinetic energy. How is that related to its mass? And how is that related to its velocity? What do you know about that? What I know or what you think? Okay, go ahead and hit pause, write something. Okay, hopefully you took a moment to write something down. Let's start with Roman numeral 1. We're going to be looking at kinetic energy, mass, and velocity. Um, Kinetic energy, mass, and velocity. Okay. These blue vocabulary words there, they're hyperlinks. Go ahead and, in your own time, click on each of those and make sure you're comfortable with the definitions. Okay. Um, if we take a look here, recall that kinetic energy of a moving mass, is proportional to its mass, and it's proportional to the square of its velocity, right? Magnitude means the strength. Okay, so if we were to write this out as an equation, we could go ahead and we'll take this equation, clear that screen, and let's just take this equation right here because they provide it for us, right? To calculate dot dot dot, we take we say that Ke, kinetic energy, is equal to 1/2 times the mass times the velocity, and you square that. Okay. Um, as our mass increases, our kinetic energy will increase. As our velocity increases, our kinetic energy increases. So as mass increases, so does kinetic energy. It increases. Um, and that's vice versa. As mass decreases, so does kinetic energy. That's why we say they are directly proportional. We could also say, right, as the mass, and if I were to just take the V and make that green, as velocity, right, that's speed and direction, as velocity increases, so does kinetic energy. And as velocity decreases, so does kinetic energy. That's why we say they are directly related. They are directly related, aka proportional. Okay. Now, you can rearrange, and I think that they kind of talk about this. It is possible, they say, to rearrange the equation to solve for different variables. Okay, you guys have some skill in that. If I wanted to solve for velocity, okay, so let's say I have to solve for velocity, which is, we're going to say is a v, right? What do you have to do? To solve for velocity, well, we would take our kinetic energy, which is equal to 1/2 times mass times, let's move this up there, times mass times velocity squared. And I need to get the v all by itself. So what I can do is I can multiply everything on the right by 2. So I can go ahead and say times 2, 2 times everything. And that 2 is going to cancel out. And what you do to one side, you do to the other. So we say times 2. Okay. And then I could get rid of the mass by dividing out the mass. The mass divided by the mass. What you do to one side, you do to the other. And then the last part is I would have to get rid of the square by doing the square root of the square. And that's just going to leave me with v all by itself. But what you do to one side, you have to do to the other side. So we have velocity. If we clean this all up, what we have is we have, therefore, velocity is equal to the square root of 2 times the kinetic energy divided by m. Okay, so we just did some rearranging of our formula to solve for that. Now, if we want to solve for mass, let's just go and do that as well. Okay, to solve for mass, dot, 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 and this is what we would do. Kinetic energy is equal to 1/2 times mass times velocity squared. This time we are trying to solve for the mass. So we need to get the mass all by itself, right? So same thing. I could go ahead and multiply this whole expression by 2. 2 divided by 2 will cancel out. What you do to one side, you do to the other. Now I need to divide out the velocity squared. Divide out the velocity squared. V squared divided by v squared cancels out. What you do to one side, you do to the other. So now my formula says mass is equal to 2ke divided by v squared. Okay. Practice, take time with that. And if we go back over to the left side here, you have a nice exploration, a video segment, and then you just have practice problems. In this first practice problem, what is the kinetic energy of the ball just after it is kicked? Okay, they give you in this problem the velocity, right? They give you the mass, and they want to know what the kinetic energy is. So you just have to plug those numbers in, and that'll give you an answer for that. Okay, and they go ahead and walk you through that whole solution there, and you have some example problems all these example problems are asking you to solve for kinetic energy. And then the second set of problems down there, they're asking what is the velocity, right? They give you a mass, they give you the kinetic energy, so you have to rearrange your formula to solve for V. And so that's where you can see that they're solving for V right there, and just like we did. Okay, so go through the problems, practice your calculations. You can do it. I know you can. This is becoming familiar territory. And then you have 3 problems, all of them related to solving for velocity. All right, I hope that was helpful. Trying to keep this one quick because it's pretty straightforward. And let's just have you write a summary paragraph. All right, guys, we'll talk to you soon.